Hey, it's Mr. Shrum, and today we're going to look at atoms and elements. And the objective here is to describe the Bohr model of the atom, if you recall that from our previous lesson, and explain how the model of the atom has changed over time in relation to the elements. So for the warm-up, an element is a substance that's made of one kind of atom. There are 92 naturally occurring elements that make up everything on Earth. And a good way to think about these elements is to compare them to the letters of the alphabet, the English alphabet. Letters can create words, and elements can create substances. And you can find all substances that are made of these elements. And you may be familiar with some of these elements already. Choose one of the elements shown here and open up your notebook tool and then maybe write one or two sentences about the elements that you know. So we're going to look at gold, silver, oxygen, and other types of elements right here, and it'll describe a little bit about each one. Gold is a lustrous element, and lustrous means very good for jewelry or like shiny things. It's quite expensive because it's not found in large quantities in nature. The name gold in Latin is aurum, and that's why the chemical symbol for gold is Au, because of its Latin root. Silver is a white metal, and it's also used for jewelry, coins, and metals. The name for silver in Latin is argentum, and that is why Ag is the chemical symbol for silver. So back to Latin again. Oxygen is a gas found in air. We take in oxygen when we breathe, and oxygen supports combustion or burning of substances. The chemical symbol for oxygen is O, so that one makes sense. Carbon, diamonds, if you've ever seen a diamond before, are made of the element carbon. Diamonds are very hard substances, and they're used in jewelry and are regarded for their beauty. And the chemical symbol of carbon is C. But so much of life is made up of carbon. It's not just in diamonds. Hydrogen is a very light gas. Hydrogen doesn't help in burning, but it can be explosive. Well, it is explosive. And the chemical symbol for hydrogen is H. Chlorine is a greenish yellow gas. It has a lot of uses in several industries. Swimming pools use chlorine to keep them clean. And the chemical symbol is Cl. Iron is a common element. Objects made of iron are found almost everywhere. It's mixed with other metals to create alloys, and a very common alloy is steel. And the chemical element name for iron, or the chemical symbol, is Fe. And that comes from its Latin root as well, ferrous. All right, so now that's the warm up. And now we're going to get into the juiciest part of this lesson. And we're going to talk about the structure of atoms. Many forms of matter are found all around us. They're all different from one another. However, all forms of matter are made from just 118 different substances. These substances are called elements. Each element is unique. Some elements are solids, liquids, some are gases. What makes each element unique? Well, each element has one kind of atom. It has its own signature atom that comprises of each element. Scientists have identified 92 elements in nature, and they've been able to create 26 new elements in laboratories or artificially. All of these elements are listed in the periodic table. And this takes us to the periodic table. Shows you all the elements. And scientists have given each element a symbol to make it easy to represent each element. How do the atoms of each element differ? To find out, we're going to complete an activity or look at this activity. Open the atom building simulation. The simulation allows you to make atoms from smaller particles called subatomic particles. Subatomic means under the atom or within the atom. So that means smaller particles are subatomic. To begin the simulation, click atom, and the X on the screen will represent the nucleus or center. Protons, neutrons, and electrons are the subatomic particles. Drag several different particles near the X to determine where the particles belong in the model, then answer the questions. Experiment with the simulation as you complete the activity. Click the refresh button to clear your particles. So here we go. Atom. So that we've just created hydrogen. Let's see about. And then we've created helium, lithium, beryllium. So you see what's happening, right? This chart is organized in a certain way. And let's see if you can figure out the process yet. So that was a hydrogen ion, and now it's a neutral atom. Since we added a negative electron, now we have a negative ion or cation. But anyway, you can work with that and have fun with that. And then answer these questions. Protons and neutrons are found in the nucleus, while electrons in this model are found in the circles or orbits around the nucleus. If you add more protons, what happens? Well, the element is different each time a proton is added to the nucleus. The circles or orbits for electrons are called energy levels. Each level can hold only a certain number of electrons. Add electrons to each level until you can't add any more. How many electrons can each level hold? Well, the first level can hold up to 2 electrons, but then after that, it can hold up to 8 electrons in each level. In what order does this happen? Well, the first level fills up with 2 electrons before electrons can be added to the second level. And this is the Bohr model. Although we can't see inside an atom, scientists develop models of the atom based on experiments. The simulation used in the last page used the Bohr model, and he developed that in 1915. Here's what the activity showed us about the main features of the Bohr model of the atom. There are 3 kinds of subatomic particles: electrons, protons, neutrons. The number of protons determines which element the atom is. This number is called the atomic number. Protons and neutrons are located in the nucleus. Electrons are in energy levels surrounding the nucleus. The first level holds up to 2 electrons, and the second level holds up to 8 electrons. So fact check or information check. Let's see if we can answer this question. I'm building a carbon atom. I've been told that the atomic number of carbon is 6, which means it has 6 protons. The number of protons equals the atomic number. The carbon atom I'm building has a total of 12 particles in its nucleus, which means that I need to use 6 neutrons. So the atomic number equals the number of protons, 6, but we're told that there are 12 particles in the nucleus. There are protons and neutrons in the nucleus, so the remaining particles have to be neutrons. The carbon atom I'm building has 6 electrons. These electrons are found in levels. The first level has 2 electrons, and the second level has the remaining 4. Here's the charge and mass of subatomic particles. So you can go back to the simulation, but I'll just go through the answers here. And we saw before how adding electrons changed the electrical charge. If the atom is charged, it's called an ion. Determine how to make positive and negative ions. So when there are more protons than electrons, the atom becomes a positive ion. If there's more positive subatomic particles than negative, it's a positive ion. If there are more negative electrons than positive protons, the atom becomes a negative ion. What's needed to build a neutral atom? Well, to have a neutral atom, the charges have to be equal. So the same amount of positive particles have to equal the same amount of negative electrons. So if you do what part C says, the mass number of this atomic or the carbon atom will be 6 because there's 6 protons. Atoms are unstable unless they have a similar number of protons and neutrons. To make the carbon atom stable, add 6 neutrons to it. What's the mass number now? Well, that would be 6 plus 6, which is 12. So in terms of particles, what is the mass number equal to? It's the number of protons and neutrons in the nucleus. So I'll quickly show you that carbon one. Yeah. So carbon has 6 protons in the there we go. So we have 6 protons. And then we're going to add 6 electrons. So 2 in the first level, and then the remaining, the remaining 4 in the, it's not cooperating, in the outer layer. There we go. So 1, 2 in the first level, 4 in the outer level, and then we have a neutral atom, 6 carbon, 6 protons, and 6 electrons. And then we have the mass number here, 6. Net charge, it is 0, neutral. However, we can see it's unstable, and we need those neutrons to make it more stable. And each time we add a neutron, you see the mass number goes up until we have 6 protons, 6 electrons, and 6 neutrons. The mass number is now 12 because 6 protons plus 6 neutrons equal 12. And we have a net charge of 0 still. All right, so that's how we stabilize an atom and have a neutral charge. So let's review what we learned from the activity about the charge and mass of subatomic particles. Protons are positively charged particles. Electrons are negatively charged particles. Neutrons are neutral. They don't carry any charge. When an atom has equal numbers of electrons and protons, the atom as a whole doesn't carry any electric charge. That is what is called a neutral atom. The mass number of an atom is equal to the total number of protons and neutrons in the nucleus. Electrons add very little mass to an atom, and they're not included in the mass number. That is why we only count the protons and neutrons. So it says go back to the simulation again and play a game about mass number, click game, and then click the picture of the mass balance. So we'll do that. Oh, whoops, wrong game. Click game and then click the picture of the mass balance. Did I click the wrong one? No, looks like it. So that is a +1 charge because there's only a proton, no electrons. Protons, 9, electrons, 9. So the charge will be 0 because protons are positive, electrons are negative. What is the mass number? So that is the number of protons and neutrons in the nucleus. That would be 2. 8 protons, 10 electrons was the mass number. 8 protons, 8 neutrons, 10 electrons. We only count the protons and neutrons for the mass number. We got 16. There we go. Protons, 9, neutrons, 10, electrons, 10 was the total charge. Now we only look at the protons and electrons because they have a charge. There are more electrons, just one more electron than protons. So it's a -1 charge. Wow. We did so well. Yeah, it's a fun game to check your understanding. And now we have, oh no, okay. So we have another question. We have helium, carbon, oxygen, sodium, and chlorine. And we have their atomic numbers, number of protons, number of neutrons, and mass number. So we're going to use this information and our knowledge that we just learned to fill in the blanks. And I'll see you guys next time, but we'll pick this up where we left off. All right, bye-bye.